Hello and welcome. So we are going to have a revision session on the quiz contents of ML practices, which will contain first 4 weeks. So how is the preparation for the quiz going on? Anybody would like to speak? Any contentious topics? Any idea on how to prepare for the quiz? So how is it that you're preparing for the quiz? Anybody would like to speak up?
She wasn't here.
Hi.
Yeah. So I kind of was slightly surprised by the mark quiz. I had put it there also, but otherwise, I think basically I was trying to go through. But definitely, looks like we have to look at the code very closely.
Okay.
I was
Sorry,
not expecting it for the quiz, right? I was thinking the quiz will be more on concepts, right? And then the code we don't have to. I mean, code may be there in the practical exam, proctored exam, but that is one change I'm making after seeing
Sorry,
the mock
after
question.
seeing the mock, you found that there are questions on code, is it?
Yeah, like that thing about read CSV, you have to pass that names variable.
Okay.
These are, I felt, was a bit more of syntax questions, right? And of course you can also expect that as a learner you should know the full syntax by yourself, but since this thing has so many options, not just one, right? So each function has so many options. Pretty much, I think everybody seems to just do a thing and let the collab suggest the names.
Right. So I'll talk about that. So Srinivasan, so in ML practices course, what kind of conceptual questions that you were expecting? Because we are dealing with the libraries, right? So I want to hear from you.
Question about the training model, the sequence, that kind of a part. But I understand there has to be a mix, right? It can't be only one. And MLP, I'm sure, is going to be the toughest thing to set a conceptual quiz, because there are so many practical things.
Conceptual questions mainly go in MLT, as you know.
Yeah.
Right? So
it's a tough part. I agree. But I'll just have to prepare. That's right. That's fine. And now I know that I'll have to accordingly look at the code, ensure that I have not forgotten things.
Yeah, but your concern is valid that you mentioned for example, read CSV, right?
Yeah.
We did not read CSV, so their header is being asked for. So actually, there, if you open the documentation of read CSV, there are, I guess, more than 30 parameters, right? And it is not possible for for anybody to remember all the attributes and knowing about all the details. But then there are some very important parameters which we, whenever we read, whenever we make use of that function, we'll be using that more or less. So that is why a couple of such questions have been introduced, and they are actually to encourage some sort of memory. So of course, you can go to, whenever you have to make use of it, you can go to the documentation, or collab suggests you. So that's the way out, and mostly people follow that. But when you do remember the main attributes, things get very quick. I guess you would have felt that by now.
Yeah.
So going to the documentation is always the option, but some attributes, if you remember, your coding gets very fast. And for example, we are going to be having the proctored exam, so there'll be a time limit, and in any exam that you sit for, there's always a time limit. So searching through the documentation takes a lot of time, right? So header, for example, there I'll get to that question. So header and names attributes are the most important ones, and we expect the students to be at least remembering these attributes. So that was the main reason to put these questions there. So that was the idea of keeping them in mock. Okay, so what we expect from you in the quiz is to be knowing about the main attributes. I know there's a thin line there. What are the main attributes and what are the not so important attributes, but at least the ones which have been discussed in the lectures and or in live sessions. So those ones you are expected to be knowing some detail about those attributes. Okay, so moving on to quickly revising the week's content. So week 1, mainly what we expect you to be knowing is how to load data. So of course there is introduction. There is an MLM, ML end-to-end project. There are many things, but we won't be asking questions as such from the new things that are there. That is just for you to understand the workflow, and eventually you will be knowing about all those details. So loading data questions certainly will be there.
Yeah, sorry, one question, by the way, Anamika, I wasn't sure till yesterday it was not answered. What is the syllabus for quiz? It's only till week 4, right? Because there are week 5 questions in the mock.
Oh, is it? Which question?
There were questions about the logistic regression. And
1 second, I think.
Actually, SPM. There were SPM questions.
Oh, is it?
Yeah.
Question number.
Sir,
the last two were.
I think I can answer for that.
Yeah.
So, sir, that question is not about SVM. It instead of SVM, you could have put any other classifier also that would work. So, if you look at the question, it is not asking about anything specific about SVM. It's more about SVM is just consider it as some classifier. Okay, and that code snippet, you can imagine that it is not part of. There's no detail about that.
I know. We just had to multiply the number of variables. That was the answer. A number of options. 2 into 4, I think, was the answer. But maybe okay. Then fine. So it is this anyway. Wait till week 4 only, right?
Yeah, it's week 4 only.
Okay. Thank you.
Yeah. Okay. All right. Okay. So as we know, the first step to any model creation is to load the appropriate data. So there are various options that we have for bringing in data into our code, and in sklearn there are 3 options that we make use of. So there are loaders, and there are fetchers, and there are generators. So loaders, basically sklearn itself is bundled with some data sets which are not huge. They are small data sets, but they are good enough for trying out our model for, let's say, just for testing whether our model is working fine or not. So these are toy data sets which are part of sklearn itself. We don't need to download them explicitly. So that's what we can download using load underscore the options will come, which I'll just talk about. So that's one kind of that's one option through which we can bring data into our code. So loaders is the first option. Second, we have fetchers. So what it does is it downloads data from different sources from internet. So there are you can give the name of that particular data set. There are 2 options. One is you give the name of that particular data set, for example, fetch California housing, or there is another option which is fetch OpenML. So these are 2 different options. I'll show you all these options. So OpenML, as you might know, it's a repository which consists of different data sets for practice, research. So people can upload them, and they are free to download. So that's what OpenML is, and sklearn provides us fetch underscore OpenML function to be able to download data from these resources. So all we need to know is the link, and that link gives us an ID. So that ID is what we use as a parameter. Okay, third option is generators. So generators are used to synthetically generate data. We provide how many ever samples we want, how many features we want. So we can generate synthetic data both for classification or regression, and also for clustering. So that's what generators do, and the syntax is make underscore appropriate character we give. The string we give for classification we give make classification, for regression make regression, and then for clustering we have make blobs. So accordingly we have various options. So let me quickly run through different options. Before that, what we need to import for using all these 3 options is sklearn.datasets. So that's the library. So we write from sklearn.datasets, import whatever dataset we want to import, and return type is something that is important for you to understand, because that's how you will go on further. So the default return type from these loaders and fetchers is a bunch object. Now, what is a bunch object? It's sort of a dictionary, which you would have understood in Python. So dictionaries have keys and values, right? Key value pairs are there. So this bunch object has two keys. One is data and second is target. So what data contains is it's the feature matrix, and target contains the label vector. Okay, target vector. So that's the default return type. And data and target, they both are pandas objects. So data is pandas data frame, and target is pandas series. So that's the default return type. And you can always convert them into numpy if you want. So I mean, that depends on you. And also you can give a parameter return xy is equal to true. So in that case, it doesn't return you a bunch, it returns x and y explicitly, right? So bunch is one object which is a collection of two things, data and target, which you can separately access later on. But if you want your loaders and fetchers to return two different things separately, that is x and y, so you can use this parameter return xy is equal to 2, which is by default false. So that's about the return type. And then if you talk about the return type of generators, that is x and y by default. So whenever we load some data, it's a good idea to check the return type and then accordingly use functions going ahead. So okay, that was the basic introduction of all these. Now let's look at the different options that are available for us in loaders. So we have this standard ABC dataset, which is load iris, which we would have used extensively so far, which is a classification dataset having only 150 samples and then 3 features. Similarly, we have load diabetes, load digits, this one is for regression, multi-output data, and then load wine. I think this one was used in week 1 itself, and then load breast cancer. So these are different options that we have available for loading. So they are a part of sklearn library, and you don't need to explicitly download them. So basically, they are good options to start with. Any model you want to create, it's a good idea to test on these toy datasets, and then later you can apply your model on any real world dataset. Moving on to fetchers. So in fetchers, we have a little big datasets as compared to the small datasets that we were having in loaders. So in fetchers, you see these are the number of samples. So they are pretty decent to work on model of considerable size, and there are a good number of features as well, as you see. And there are options for multi-class multi-class classification, and there are text datasets as well as image datasets and regression dataset. This California housing dataset you would have extensively used for regression. So these are different options. So what we expect from you for the purpose of quiz is at least the dataset that have been discussed in the lectures or in live sessions. You should be knowing some details about them, and about the attributes, not all, but the ones which have been used. So that much we expect from you for the purpose of quiz. Okay, moving on to the generators. So you can generate data for.
So ma'am, one question, like when you said like the expectation is to at least knowing some fact about those data, right? So say for example diabetes or your wine data, or say for example KD99 cup and,
Right.
and California housing, right?
Right.
Do you want us to even remember the number of rows and number of columns shape
No,
of
no.
the data?
No,
Not like that,
No,
right?
no.
Okay.
For the purpose of quiz, we don't want you to be knowing that. I mean, that's not possible also. You can't remember all those details. So
Correct.
like I said, like initially Srinivasan had asked about the header question, header and names question. There is that is there in mock. So they are very commonly used attributes. So it is, and they are used in some live sessions or some collab in the videos. So that much we expect you to be knowing, right? Some
Yeah,
most
understood.
commonly used attributes details, not the
Understood.
number of attributes. Okay, for regression we have this make regression function that we make use of. We'll quickly run through some of the attributes also in a while. For classification, we have make classification and make blocks. For multi-label classification, we have a separate one, make multi-label classification itself. All right, so okay, I'll show the collab in a while to see how they function. And then for clustering, we have make blobs. So basically, it creates different clusters, and so they are these clusters, the elements that are there in these clusters, they have some mean and standard deviation, and accordingly, a different value of the cluster is assigned to each of these cluster elements. Okay, let me show you that in the collab. So fetch open ML is another option that I was talking about, fetchers. So as I showed, for fetching, you have all these data sets where you are explicitly giving the name of the data set, fetch underscore dash. So that's one option. Second option is fetch underscore open. Yes.
If you don't mind, so when you are saying that we should know the information about data set, so are we talking about the type of data it is, or what type? It's a regression or a classification type data, like that?
No, you're not expected to be knowing for a given data set whether it is regression or classification.
So like what
For
are
quiz,
the...
you're not expected to know. If there is, when there is a proctored exam, of course you can load the data, I mean, during the exam, and then you can see whether it is classification or regression. So you can have such questions there, but not in the quiz.
So, but if you give a very like a very vague example, so what we can expect, like very vague?
I'm sorry, I didn't get you. Very vague example, as in?
As in, if for example you said we should know about the data sets which are actually at least discussed in the lectures or in the for example in the live sessions. So if I'm not wrong, we have discussed around 4 to 5 data sets, right?
Yeah, yes.
Yeah. So if I'm saying that, for example, there's a particular question belonging to the California data set. So are we expected to know about the graph which is there?
No. You are not expected for quiz. You are not expected to be knowing, internal details of those data sets. So more or less, mock questions, I mean, not mock, quiz questions will be self-contained. Right. Okay. Let me quickly show you the kind of questions you would have seen in quiz also. So if you look at the questions, okay, pertaining to week 1, if you look at the questions, the kind of questions that we are asking are to load digits data set from sklearn, which of the following is correct. So now you should be knowing this function at least, right? Load digits. Okay, this is
got it.
This is the name of the function itself. I mean, we are not going much into the details of all the attributes, which may be 30 to 40 attributes. You are not expected to get into details of all of them. So this name of the function that you are expected to call is something that you should be knowing. And then this okay, let me cover the questions now, only now that you spoke about it. So second question that we are asking is for the sequence. So ML end-to-end videos, which are I think first to fifth videos in week 1, you're not expected to be knowing the internal details of all that is covered in end-to-end. Okay, so this is a very basic thing, that you should know the sequence when you are building an ML model. So this question pertains to that sequence, like first you choose a model and then you train it, and then you evaluate it, and accordingly you tune the parameters, and then you use it for prediction. So that's the very basic thing that you should be knowing about the sequence.
Yes.
And now coming back to the expectation of what all you should know. So here, we are making a data set using make regression, right? And the code is also given. So this is sort of a self-contained question. Now what we are asking, so you should know what this attribute means, right? You should know what this attribute is doing, what these attributes are doing. Accordingly, you would know what will be the shape of the data type that this function returns.
Yeah.
These are some
Correct.
very, yeah. So this is what I meant by saying that whatever attributes have been covered in lectures and live sessions, at least you should know those details. So this was extensively covered in live sessions, right? So this directly tells you what will be the shape of the data that you get. This is one thing that you should be knowing. This is from week 2. Yeah, this is something that I think some people were concerned about. Here we are asking about one of the attributes of pd.readcsv. So out of all the methods that we have discussed for loading data, they were from sklearn library, right? Now there is one more option in pandas, which is pd.readcsv, through which you can load any CSV into your code. So this CSV could either be on your computer or it could be an online link. So you can use pd.readcsv for getting data from any source. Now there are
But we haven't discussed pandas in that detail.
pd.readcsv is not
Yeah,
used
we
in
know about the
anywhere
read
first
CSV.
4 weeks.
No, the read CSV part was means I mean, if I'm not wrong, we use the sklearn library only, and in the sklearn library we have there's a part called as frame. As frame is equal, we have to put
Yeah,
it as 2.
that's one
So
attribute.
over there we know that it's a frame. I mean a data frame, but like precisely we have. I don't think so. We have used pandas excessively. We have
No,
just
I
used
think
it to read the data set, nothing else. If I'm not wrong.
I
Now
think there was
PT dot
one
yeah.
live, I mean, maybe either live session or one of the video lectures, there was a CSV reading. Maybe in the live
I
session,
think
maybe
week
SWI,
4 by
maybe.
Jimmy. I
Yeah.
think Jimmy used pd.readcsv. Are you there, Jimmy? Can you?
Yeah. I have used that.
I think I'd seen it somewhere. That's why I thought it's a good.
I'm not saying we haven't used. I'm saying we have used, but only for the purpose of reading the CSV, not for the extra attributes which pandas offer. Just like for
Okay.
example, reading the parts. No anything else. Nothing else. Like 2 things I know: reading the CSV and calling the head function and the info function and the describe function. 4 things.
All right.
Ma'am, actually there are quite a lot of concern regarding that NumPy and pandas, right? So probably like you can kind of a plan for at least one session with pandas basic functionalities like this reading a file, data frame series, and indexing, and
Okay.
little bit on group by. Correct, because these are the
Okay.
basic things. Like if you know, you can just play with your data.
Yeah.
And I'm sure that in like I know about the read CSV header function, but I'm sure most of the people won't. And also in that and also for example, we had one session in MLT for NumPy, specifically for NumPy.
Yeah,
We
that's what. So the NumPy was covered there in a decent
yeah
detail, right?
yeah. Say we want something in the pandas
Okay,
also.
pandas is what you're asking for. Okay.
Yeah, because I don't think so. Most of the functions, even I am aware of, because it's just because we are just now introduced to pandas, and also it's scikit-learn is the main focus library, right? So we haven't discovered pandas in detail. So that's what I'm asking.
Okay, so actually, let me honestly tell you the motive. My motive was to put these 2 questions, specifically question number 5 and 6, in the mock itself, was to sort of convey that some important attributes you are expected to be knowing, and that's actually for your benefit only. As I said, if you remember some of the main attributes, rather than checking the documentation every now and then, it makes you a fast coder, which will be beneficial for your proctored exam and any coding for that matter. So that is why these 2 questions were actually put in mock.
Yeah, ma'am, actually that is absolutely legitimate. Okay, like because this is good that you pointed the attention through this mock exam, like okay, keep a eye on the at least these APIs, and these are very common APIs, right? But since like pandas even after this MLP program, right, like if you do not know if say for example like candidate doesn't have any knowledge on pandas or like very minimal knowledge on pandas and have lot of knowledge on sklearn, that will also not make much sense.
Yeah,
right?
you play around with the data using NumPy and pandas. I hope you would have seen by now. That's how you play around with the data, right? As in,
Yes,
for
precise.
example, pre-processing. If you have to do, there are pre-processing libraries in sklearn, but still, they might not be sufficient if you have to really get into the inside details of the data. Let's say, for example, you want to see whether missing values are there or not. NaN you can check using sklearn functions, but let's say these missing values are replaced by something else, let's say question mark. I mean, you need to get into the details of the data that's only how you can know what customized pre-processing you need to apply to the data. So for that you need pandas and data frames. I'm sorry, NumPy and pandas for sure. Okay, pandas we can actually plan some session. That's not a problem. That's not an issue. We can plan and we'll let you know. Yeah. Okay.
Yeah, thank you, ma'am.
Yeah, sure, no problem. We will actually have been discussing about this thing, pandas and NumPy, that all the students have to be very much familiar with these two. So we actually heard about some student led activities in this direction. Some students were going to have were having, I mean, I think yesterday some session did some session happen on
Yes, that some session happened on NumPy.
NumPy. Okay, not in
But
pandas.
yeah, it was like pretty like elementary level.
Okay.
But yeah, it's good, but something is happening.
Yeah, it's really good. I mean, we all actually encourage you to be doing such things and helping each other. Okay, so NumPy was covered in MLT week 1, and NumPy yesterday also you were saying was covered. So pandas is something that you people want, right? Okay, we can plan that. All right, so this is what the kind of questions we have asked from week 1. And regarding the attributes, so solid instructor session happened, and I think most of the attributes were discussed there. When you use make regression, number of samples and the number of features, all these attributes you should be knowing about. And let's say you use make classification, then number of features, number of informative features, number of redundant features. So that number of features is actually a sum of number of informative and redundant features. It should always be greater than that. So this much detail you should be knowing. I mean, if you have practiced, you will actually know. There's actually, I understand there's a thin line between how many attributes you should be knowing and how many you can just skip. But that's why I gave this sort of benchmark, that if these are covered in live sessions, you should be knowing about them, right? So I think that should be sufficient. So yeah, so I'm just running through some of these things that you would want to refresh before the quiz. So for clustering, you use make blobs as we discussed, and then the parameters as same as number of samples, number of features. And for specifying the clusters, you use an attribute that is centers. So you should be knowing that, right? Centers is the attribute name that you use for specifying the number of clusters. So that you should be knowing. And then loaders, we are taking an example of load diabetes. So here you see we are giving return xy is equal to 2. So let's say we ask you what will be the type of the return type. I mean, what will the type of the thing that is returned by low diabetes, return xy is equal to 2. So okay, there was some change here. So if you don't have xy, you just have diabetes data here, so that will be a tuple. Okay. Okay, I should so you need to play around with these things. This is the basic thing that is expected from you. Okay, it's taking time. All right. So, you know, so this is a NumPy array, but let's say you don't mention this, then by default it is false. In that case, whatever is written by low diabetes will be of the type of pandas type. So it will be bunch, and bunch will have data and target, which will be of pandas data type. So all these things you should be knowing. All right, so and then fetch KDD cup 99. So that's an example of a fetcher. And then what is the what attribute you can use to get the names? So that's feature names. So that's one thing that you should be knowing. And then shape. Of course, we won't be asking you what are the number of features and samples in these data sets. That's not what we'll be asking in quiz at least. All right, so I think okay. Finally, this is fetch OpenML, where we give the ID of the data set, and that's how we download from OpenML. So that's another thing. Okay, so that was pretty much a revision of week 1. So,
I had Srinivasan here. I did have one question. So
Yeah.
basically, the way I resolved was that I have to go read this code also as preparation for the quiz.
solve the structural code.
Yeah, all this code. Of course, this is not shared. So I have taken a copy because whatever I did, but that seemed to be one thing that I have to read.
Okay, so actually, sir has covered all this as a part of videos. So
Yeah, that is covered. Yeah, the same thing, right? So let's say the code part, I had not looked at it till now. That's why in the morning, in the
Okay.
beginning, I said, now the code part also I will look.
Yeah. So to be knowing about the attributes, the important attributes, you should, because MLP is all about that only, right? I mean, there are no concepts as such. So, I mean, MLP is all about sklearn library and its, functions and their attributes. So you need to go through the code to be, to prepare for the quiz. That is there. Okay, so I think that was pretty much it. DJ will continue with week 2 now.
Yeah, okay. So hello guys. So let me share my screen. So everything you have obtained, the solve with instructor and solution PDFs, everything is in portal, right? Just let us know if the documents are not in portal. Okay, obviously upload everything if required.
All
And
the instructors, I don't think they are in the portal unless I'm mistaken. The solutions to the assignments are in the portal, but I don't think SWI code is in the portal.
SWI, yes, Srinivas is right. Unable to find SWI Python sheets.
Okay, so we'll take a look into it. They should be there, but if it is not there, they will be provided.
okay, yeah, so that's helps a lot. Thank you, Swarnim. So we will discuss. Let us discuss. We will not take much time. So week 2 is mostly data pre-processing. Sorry, as you all know, Srinivasan sir was also. Yeah, we remember your help in the live sessions and nice discussions we had. So we will just go through the slides, and my suggestion is please go through the faculty slides which are given already, and in the live session also we showed the collab, so that will also be helpful. Some people have made very diligent notes from the collabs, and Chandan was telling in the discourse to us. So those will be nice to have, and even if you have not like reproduced the collabs itself, or if you have gone through the lecture videos, that will be okay. I mean that will help you to solve the problems. So as I think you have seen in the quiz also, and Anamika ma'am was also telling that we will not ask you for like row, how many rows are there, how many columns are there, we will not ask you. We know that it is difficult to remember. And I mean, once you have a computer, you can obviously get this all from a line of code. So it does not make a sense to, I mean, memorize all these things. Anyway, so what you should take care of is what one particular code actually does. Suppose you have imputer. Okay. So what does an imputer do? A mean imputer or a median imputer, what does that thing do? If you know that, then you can solve the question, no issue. And I think in quiz also you will have the calculator, scientific calculator. I think it will be provided. So if some mean you cannot calculate or something, you can calculate in your mind. You can calculate it using the calculator also, I guess. So we will just go through the lectures. We do not have much time, I mean, to discuss on week 2. We will, there are other important topics also coming up. But one thing is that week 2 is a quite, I think it will be a scoring portion. So just look into it, and small sums will be, small things will be there. So like, as I was telling, imputation, then function transformer, then small things about PCA. Okay, if you go through the faculty slides, that will be very helpful, I think. Okay, so let us go through the slides once, and after that we will just we can give you some suggestions, and we can move to the next week's content. So as we were discussing, so first thing is week 1 was on data loading, and then the next week is we have to do the pre-processing of the data. Now, sklearn provides a good set of transformers for this job, for checking missing values, scaling of the data, handling the categorical attributes, etc., etc. Extract the features. So these are some of the topics which are studied in this course. One major thing which was first, which was introduced here is fit transform. So fit, what does fit do? Fit learns the model parameters from a training set, and transform does what? The transform applies this transformation which we have learned to the new data. And fit transform, that is fit underscore transform, it performs the function of both fit and transform together. It is much more convenient and efficient. Okay, so in pipeline, then we use fit transform and fit also, right? Then we have different ways to extract features from the data. We have dict vectorizer, we have feature hasher, all these things are there. What does dict vectorizer do? Now it converts the list of mappings of the features names and feature values into a matrix. And feature hasher also turns the sequences of symbolic features into matrices, and it uses a hash function to compute the matrix column corresponding to one particular name. So sir has shown nice examples. You have seen the dict vectorizer. Again, just note that it converts the list of mappings of feature names and feature values into a matrix. So if we have this kind of data, age and height, age, height, and age, 4 rows of this kind of data, then what it does is, once we apply dict vectorizer, it gives us a transformed feature matrix where these are the columns and these are the column values. Okay. Similarly, we have feature hasher also. Sorry, feature hasher also we have. So we have a, as you have seen in the slides, so we have a high speed and low memory vectorizer, and it applies a hash function, as I was telling, to the features to determine their column index in sample matrices directly. So this is what we want is, if you can note these things, I mean, just go through sir slides, that will be very helpful. And the live session also, we have shown the collabs, okay, on the examples. Solve with instructors are also, as Swarnim sir told, so solve with instructor will also be provided. I think today only it will be done. Then just go through that, okay, that will be helpful in your in attending your quiz. Okay, so you don't I mean need to worry very much. As I was talking about simple imputer and KNN imputer, there are these two imputer values. So you know that from where do we bring these things? So we have scalar.impute. So scalar.impute provides functionality to fill the missing values in a data set. Then you know that how does simple imputer works. So simple imputer uses these strategies: mean, median, most frequent, and constant. So in your mock also you have seen we have given some of these things. KNN imputer I think was given. So KNN imputer uses k nearest neighbor approach, okay, to fill the missing values. In our live session, we had a very nice discussion on KNN imputer. You can go through the YouTube video once, and it will be available. So missing value is filled with the mean value of the same attribute of n number of neighbors, in number of closest neighbors, using the Euclidean distance. So these small things, right? So I can ask like, what are the, how do we calculate the nearest neighbor in the KNN imputer, right? So we can calculate it using the Euclidean distance between the points. This kind of small thing. So I can say that this is the nearest neighbors in KNN imputer are measured based on, say, some other form of distance or Euclidean distance. Is this true or false? So you can say this is true. Small things like that. So we have an example of KNN imputer, and as we have discussed it in the live session, we'll not waste much time. Yeah, you can see that how the KNN imputers are working here. What else? So there is a missing indicator which helps us to get the indications and returns a binary matrix, and etc. etc. Feature scaling is there for numeric transformation. So you can use different feature scaling. So we commonly we use standard scalar and min max scalar. So of course you know what is the underlying principle of standard scalar, right? So it uses the mean and the standard deviation. Okay, so that is how. So we can see that if you give us a small matrix like this, and you can ask, we give a code to operate standard scalar on them, you can immediately, even without a calculation, if we give you this matrix, you can see that you can calculate the output as well, right? Because you know that this is the mean, and maybe the standard deviation also is quite easy to calculate maybe here. Okay, some things like that. And then we have min max scalar. Min max scalar also works on this principle, which is shown in the purple color, very beautifully shown. That so you can use x minus x mean value and x max value. Okay, so you can see that how this is how the min max scalar will operate. So we can give, say, different options. Okay, so one of the option shows the correct min max scaled output, right? So that can be also that is also a probability. Those kind of things are there, can be there. Okay. Apart from that, similarly, maxab scalar also is there, which transforms within so that all the values are within the range -1 to +1. So it divides by max absolute value. I think as far as I remember, we showed you a sensor data also where we actually showed that how the +1 to -1, the data actually is scaled so that we can extract different characteristic features. Polynomial transformer is important. So polynomial transformer, you can use different function transformers. See this log2 function, suppose. Even if you don't know, okay, if we give you a small value, okay, small few numbers, as you have seen in the mock also, okay, even if you don't know the exact code, you can understand that, okay, this will be the output, right? This can be the output. This is a possible output here. If you know that, so for a log function, you just have to log to all the elements. Okay, so then similarly for log, there can be exponential as well. Okay, there are different functions. As sir has told, there is a log 1p, etc., log 2 here. All these things are there, right? Polynomial transformation is important. Polynomial transformation, it generates a new feature matrix consisting of all the polynomial combination of the features with degree less than or equal to the specified. So we can have different, you can see different degree equals to 2 is given. So therefore, if we had x1 and x2, we have x1, x2, then another 2-degree polynomial, which we can have again, max 1, x1 into x2, x1 square, x2, x2 square. Similarly, degree 3 also, these things are there. So then we have one famous thing, one hot encoder. Creates a binary column for each of the k unique values. So if you still did not have very clear idea, we had a long discussion on one hot encoders. You can check the sklearn manual also, okay, on one hot encoder. It is written very useful way there. And so you can see that you have exactly one column has 1 in it in the one hot encoder, and rest have 0. So you have one column, 1, 2, 3, and 1. So you can see here are, so 3 numbers are possible. 1, then we have 2, and then we have only 3, right? So 1 is there twice. So 1 is twice, 2 is once in the second row, and 3 is there in the third row. Okay. So this is the matrix which we are getting. Then we have similarly label encoder, which encodes the labels within the value between 0 and k minus 1. K is the number. Mostly these are from data preprocessing. From data visualization, we had small sessions on the violin plot, box plot, all those things are there. So you can check those things, but as you understand that it is sometimes difficult to check, to review your answers based on a visualization data. Some questions may be there, but we may not expect many questions on the data visualization. But please do not leave it. Please read it also. Some questions again can of course be there from the data visualization. Okay, or some parts of it, like what are the different parts of a box plot. Okay, and how do we correlate? I remember we showed a video on a picture animation on how to correlate box plot and violin plot. Okay, this kind of things are there. Okay, so you can read those interesting things if required. Okay, just go through the sir slides, solve with instructor slides, solve with instructor collabs. I think it will be helpful for you to clear the quiz. Okay. Then we had okay, of course, then there is the pipeline and feature selection coming up. So in the feature selection, we have then we have select k based, select percentile, and in wrapper based selection we have RFE, RFE, CV, etc. These things are there. Okay. So these you can just go through this. Please go through the slides once. That will be helpful. Okay, let me see what else we have. Yeah, variance threshold is there. Variance threshold, it removes all the features with variance below a certain threshold, as sir has told, as specified by the user from input feature matrix. So what it does, it removes all the features with variance value below a certain threshold. And by default, it removes the feature which has the same value, that is 0 variance. Okay. So likewise, you can select k based. What does select k based do? Select k based removes all but the k number of highest scoring features. So it keeps the k number of highest scoring features and removes all the other features. Okay. So these are the APIs for univariate feature selection. In select percentile, it removes all but a user specified highest scoring percentage of the feature. So you can say that what percentile you want to keep, and you can remove the remaining parts. Okay. So this is the select percentile API. Okay. So of course, again, we have used and we will again keep using these things. Select k based, some codes are there in the slides. So it selects 20 based features. Select percentile, again, we have percentile value equals to 20. And similarly, generic univariate select is also there, which can use percentile, which is a default value. Then k-based APR, etc., we have. Select k-based and select percentile, I think will be is also important. Generic univariate is also important. And just go through them once more. Okay, just see that what are they doing, what is the underlying principle. Okay, what is the main principle on which these things operate on. Okay, of course we have pipeline. Yeah, so wrapper based selection, wrapper based methods use a estimator class rather than a scoring function. So we can just give a maybe true false statement, right? So filter based methods use it, wrapper based methods do not use estimator class rather than a scoring function. That can be a false option. Similar, this kind of things can be there. And which of the statements are true? Then we are giving this is this. These are the statements, 4 statements. Like that, you have to choose the correct statement. RFE uses the estimator to recursively remove features, and RFE repeats the processes by removing features one by one until the desired number of features are obtained. So go through search lecture also. Just see what are the topics covered there, and follow search lecture. That will be very helpful, I think. Pipeline, of course, pipeline will be there. Pipeline, again, pipeline provides utilities to build a composite estimator as a chain of transformer. So there are 2 classes, pipeline and feature union. Again, as we know, that pipeline, what it does, it constructs a chain of multiple transformers to execute a sequence of data, and feature union combines the output from several transformer objects. So feature union combines all the different pipelines and it can create a new transformer from them. Okay. And what else? So similar, yeah, pipeline you can use. The purpose of the pipeline is to assemble several steps which can be cross-value. So with that, we actually come to the end of the thing, end of the presentation. So again, this maybe you have just joined something. I'll just make a small suggestion. Go through all the faculty slides, and collabs can be seen from the live session videos. Solve with instructor, Swarnim sir told he will upload. We have given simple imputer, KNN imputer, function transformer, dict vectorizer, feature hasher, pipeline, and RFE CV. Okay, and what else can we use? Select k-based, select percentile. All those things you can just go through and learn their underlying principle that will help you in your quiz. Okay.
Hi, Nishant this side, sir. I have a question. That sir's collab file, actually I'm not able to get in some of the things are missing, right? So I heard that from week 4 we can see I haven't joined some sessions, so I may be missing something. So can we just tell us, like, if you have walked through all the collabs of sir's videos on a particular week or particular day, if I can just note it down so that I can refer wherever things are missing.
That is actually, we have already announced, I think. So week 2 you can find in the live sessions. Okay, live sessions, at least Wednesday, I remember the Wednesday week 2 live session which was there, activity practice. And I think from week 3 onwards and week 3, week 4 onwards, you can find in the first live session videos. Right, Swarnim? We actually announced mailers.
Yes.
Week 3 I can't find. So a problem with the week 3. Week 2 is fine. Week 3 onwards have problems. So
week 3 in the live session, can you check the activity?
Week 4 was definitely announced. Week 3 probably the live session may or may not have had it completely.
So can you summarize at least you have one recorded video to just walk through so that I can refer wherever things are missing. So because it will be.
Can you check the?
Sir, Srinivasan here. Can I answer that question, Nishant?
Please, sir. Please.
What this person Chandan did, and I am following that, is while the watching the video, I'm writing the code on the side. Right. So that seems to work, and for week 5 it worked, and then that way. I think probably Rajiv others also tried it because I could see that interaction. So week 5, I didn't have to look at the SWI code, right? The code at all, right? I could, because I had already written the code myself.
Yeah, I
That is
remember.
what I am doing. But yeah, week 3 seems to be, so week 3 also, basically what I'm watching the lecture, either the lecture or the SWI's YouTube session. That way you can pause the video, write it down, and then continue.
No. So actually, I'm doing on a parallel basis. I'm watching the video and writing, and somewhere when the codes are missing, I get stuck. So I'm just want to collate the information where I can refer whenever I'm going to revise things. For not even for the quiz or even for the.
Yeah, when he doesn't show the code, it is basically because that is the assignment. So
yeah, Mr. Nishan.
Yeah, please. Sir.
Please proceed. Yeah, now tell me. Yeah.
So if we can just summarize which are the actual locations I can go for, or which are the actual YouTube sessions which I can go for to watch the missing course. At least walk through the complete collab of sir's videos.
So week 2 and week 3, what I did is in the Wednesday session. Okay, Wednesday activity practice. Just check towards the beginning.
Okay. Week 2 and week 3, right?
Week 2, week 3, and week 4 onwards also we made it a practice that we are showing it on the first lecture, that is on Wednesday 11 to 1. Okay, that one you check. We actually go through that.
Okay, thank you.
Made it a custom. Yeah, just check that YouTube video.
And is it for MLT as well, sir? Is it same thing for MLT as well? Wednesday means the.
I am not.
MLT also they are doing the same thing. Yeah.
Oh, yeah. Okay, so please, my suggestion is please follow sir's lecture slides. So SWI also we are uploading. Please, go through that. But mostly sir's lecture slide is more than enough, I would say. And sir's videos, okay, that will also be very helpful. Okay, sir's videos just keep. Just listen to it. Okay, that will be all the questions are from lecture content.
Sir, actually, one question I have regarding one hot encoder. For the multi-class, multi-label, while doing in one hot encoding, I'm not able to relate with probably one of the mock questions being asked, right? I think, sorry, it's in MLT. Sorry, I mixed. Sorry, but yeah, okay. But if you can somehow answer that multi-class, multi-label.
Multi-class, I am not sure. Can anyone tell me what was?
Yeah, that multi-label, like if you use multi-label binarizer, okay, then you will get, okay, because I use that multi-label binarizer. In that case, like in say for example in first row there could be multiple columns which is marked as 1. Okay, so use multi-label binarizer.
No, if let's assume I have a 3x3 matrix, I'm just referring for MLT question for multi-label, multi-class, something like that. So all the 3x3 matrix have distinct element, but their binary encoder have one unique matrix. So I'm just not able to relate that. How is it going to be encoded?
Yeah, I think if I can help, Rajiv also mentioned it. Let me put it the other way around.
Yeah, please, sir.
In the row, if you see more than one, it is multi-label. Okay, so multi-class, yeah. So this is sorry, in the column, right? So that way, this one, right? The first label, right? There are 2 labels that 2 classes have been applied to this. Or am I getting confused? So this example.
No, you are right actually. Say for example, if it is a multi-class, then you will be making it up to 0 to k minus 1. Okay, and multi-label, like if you see the row, there can be like more than one column having 1. That is multi-label.
Rajiv, see, if I have, let's assume this example we have in the screen. If we have 1, 2, 3, 1, this is one column. If I have made another column as 2, 7, 9, 20, something different numbers, all together different numbers, then what will be is it a multi-class, right?
No. Like you are saying, like 1, 2, 3, 7, 1, 2, 3, 1, and another column is there, right?
Yes.
But this is X, right? That is the feature vector.
Yeah.
No, this is not. This is feature vector, right?
No, but you are saying your Y, right? You are asking for Y, right?
No. I am asking for. I'm asking for feature only. If I have a okay, every feature, every single column have a separate encoding. That's what you are saying, right?
Yeah.
Yeah, so whenever you have a categorical feature, right, that time you use this one hot encoding to get it numerical, right?
Okay.
But if it is a multi-class and multi-level, you can only answer if you see the y vector. If y is a vector and it has, say for example, 1 2 5 9 6 something, this is the multi-class, and that time you can use like anything level level encoder or level binarizer to get it multi-class. Okay, but if it is a multi-level binarizer, that means multi-level problem, then as Srinivasan said, right, in one row you can see more than one.
Yeah.
Okay.
Here,
More
the
than
first
one.
one.
Yeah.
Uh-huh. Okay.
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 Okay. So I think that helps. I will not. Yeah. It's too much.
No, sir,
Yeah. Tell me.
Also, if I'm just wanted to confirm, class is the feature attribute and label is the label attribute, right?
No. The class is applied for both. Sorry if I can answer. So
Yeah, sure.
class is the values are more than 2, greater than equal to 2. Okay, sorry, greater than 2. So the values that the feature can take, right? Suppose there are only 2, then it will be a binary encoder, right? So then it will be only thing. If it is more than that, it will become a multi-class. So like this, right? So you will need 3 columns.
Okay, got it.
Okay.
Just to confirm, you're saying that if I have just cat and dog, then that is basically a binary classifier.
Yes.
Correct.
It'll be it's a normal class. You don't call it multi-class because you can put 0, 1, 1 minus 1, anything you do.
And it's not a labelizer, this cat and dog in that case.
You will put a labelizer, right? You will call, say, cat is 0, dog is 1.
Okay, and if I have cat, dog, and parrot, then it is a multi-class.
Yeah, multi-class. So that will need 3 columns. So you'll have to figure out something.
So
right?
then I'll have to use multi-labeling there.
No, multi-class. Wait.
Multi-class.
Multi-class.
So your MNIST data is your multi-class.
Okay.
No, Rajiv, you cannot tell always. Okay, if you are going to predict whether the picture, okay, the picture is a cat, dog, or parrot, then it is become a multi. That means you are assigning a single instant. You cannot assign a picture with it is a parrot or a cat or a dog, right? But if you will tell you have a group of animals and you need to predict, okay, the picture contains whether it has a dog or it has a cat also, it has a parrot also. That time it become a multi-class output.
No, that is a multi-level. Like if
multi-level
you see,
output.
Yes, because Sir has given an example like that fruit.
Yes, fruit.
Correct. So that is a multi-level. But MNIST data set, your level vector is only between 0 to 9. Right? That is a multi-class.
No, because in that picture you have a single letter, right? That's
Right. Absolutely. You are
but
right.
if you are writing a number 1, 2, 3, 4, then it become again multi-level. So it depends upon the context what you are going to predict.
Yeah, that's what I said. MNIST, right? MNIST is like digit recognition. So that is the reason MNIST is a multi-class problem.
Right.
Okay, but if you the way you said, like say for example 1, 2, 3, 4, that is a multi-level problem.
Multi-level, right?
Yes, absolutely.
Thanks for the help, Srinivasan sir. So we will move to week 3 then.
Sir, I just have one doubt in a week 2 concept. It is actually an MLT graded question of week 4. The question is, which of the following method adopts a dictionary-oriented approach associating to each category label a progressive integer number? And the options given are feature hasher, label encoder class, label binarizer class, and dict vectorizer.
It is dict vectorizer. Yeah.
But the answer is given as label encoder.
Oh.
No. What is called incrementally increased. Okay, you just read. So if you are going for the dict vectorizer, it will just convert the same. Like if you have 4, 5, 6, it will just convert it to 4, 5, 6. But when you are going for the label one, The 4 is going to become 0 in the decreasing order 5, 1, 6, 2. Then it becomes 0, 1, 2. So
Okay.
it's a word called incrementally increasing. That's
Yeah.
why
Okay.
it's going to be a level encoder instead of dict vectorizer.
Okay. Got it. But all of them are dictionary oriented approaches.
Yeah,
right?
of course. Yeah,
Okay.
dict vect is also, all are dictionary oriented, right?
Okay. Got it. Yeah.
So just to confirm, then the first value will be given 0 in the label encoder, right? Whatever, regardless of whatever it is, right? It could be minus
because
100
you're
also.
starting 0, right? 0
It will be encoded 0. Next is 1, 2, 3 and all that stuff.
Yes.
So that is why the difference in values is not anything, right? It could, because minus 100 and plus 200 could be given as 0 and 1.
मार्केट तो आज धमक के ऊपर आई है, 750 पॉइंट अप है.
Okay, I think someone is just
watching the market on the side. So
anyway, we'll go to week 3. Let us finish all the weeks. Swarnim, money there?
Yes, DJ.
Yeah, okay.
Thank you.
I'll stop sharing.
मेट्रो भी आज तो गिरा ही है.
Can you please mute whoever is just watching other things? Please just.
yeah, just by the way, I am the financial advisor. I should be watching it, but I am not. So
No, let's not lose focus.
Is my screen visible?
Yes, Swarnim, visible.
Okay.
1250 तक गया यार. 1250 तक गया.
Should we mute everyone?
Yeah, you just mute, sir.
So what is the name of the person who is
Sumit Kumar sir? Yeah. Oh, he muted.
Okay. Okay, so let's go through week 3 now. So I'm going to just reinforce some of the things that Anamika and DJ have already said, that go through the Solve with Instructor sessions and go through the lecture slides that sir has created. They are very well prepared. So that should give you a very good preparation for the coming quiz. So in week 3, the revision session that I'm going to take it is actually a subset of what sir has already covered, but without all the details. So the focus of week 3 is regression with SGD regressor. And before we fit any meaningful model with it, we can start by fitting a dummy regressor, which will act as our baseline model. So what strategies can we use to fit a dummy regressor, which are mean, median, quantile, and constant. And once you have fit your baseline model, what you can do is you can start fitting a more meaningful model. And how do you do that? Now there are 2 methods to do exactly that. One is normal equation, which is sklearn, which can be applied from the API, sklearn.linear model.linear regression. And if you want to go with the iterative approach or gradient descent approach, more specifically stochastic gradient descent approach, you can use sklearn.linear model.sgd regressor. And in order to fit a model, SGD regressor model or linear regressor model, you call a fit method on the object of that regressor and pass train X and train Y values. Now the focus of week 3 is mostly SGD regressor, and a bit of time is dedicated for cross validation. We'll come to that. So SGD regressor internally implements stochastic gradient descent. What it means is it will take one sample at a time, update the weight values, and move on to the next sample. So one beauty of SGD regressor is it is very, very suitable for large datasets where you have thousands of even up to thousands of features and millions of samples. It will work really well. So in general, any situation, SGD is the method to go to in any problem where the data set is too large to be fit into your main memory. Now, it accepts 3 kind of penalty parameter values. One is L1, which is lasso, L2, which is rich, and the combination of these 2 is elastic net. It accepts 4 learning rates: constant, inverse scaling, optimal, and adaptive. It also can take different values of loss function, For example, Uber, squared error, and there are more which you can find in the documentation. We can also set parameters for the training process to stop early. For example, if we tell them maximum number of iterations, the training should go on. Maximum number of iterations, training goes without any changes. Or we can also set a value of tolerance on validation set. If the tolerance does not change by much, we can stop early on that case also. Then there is warm start or cold start. Warm start means we initialize our parameter values of the SGD regressor from previous training run. Or cold start, it starts from 0. Next is it is sensitive to feature scaling. So SGD regressor, since it takes only one sample at a time, it is it is good that we scale the features, either standard scaler, min max scaler, or anything that you feel suitable that DJ has covered before. Apply scaling on the features and then use SGD regressor. Next is how would you detect whether your model is underfitting or overfitting. And for that, you can plot a chart between loss function. Of course, loss function will go on y-axis and the number of features go on x-axis. Then how would you do the model inspection? That means you have trained your model and you want to figure out what are the weight parameters associated with every feature. That you can figure out with this dot coef underscore attribute and the corresponding intercept, which is which should be W0. How would you inference the model? It is same as linear regression. So you would have to call the predict method. In that you pass the training feature samples. Next, how would you evaluate your model? Now, to evaluate your model, you will have to split the data into train and test sets. On train set, of course, you will fit your model, train the parameters, and on test set, you will measure the scores or errors. Okay. So in this week,
Sir, can you please go to the last slide for a minute?
Sure.
Just a minute. Yeah. Yeah, thank you. Actually, I just wanted to, I read measure score by error, something else. So I thought it's a score by error, not score.
Okay. So next topic that Sir has covered in quite detail is the evaluation matrix that you can use for a regression task. First one is your old R2 square, the mean squared error, the mean absolute error, mean squared log error, then mean absolute percentage error, and mean absolute error, median absolute error, and then max error. So all the details of these 7 error metrics is being provided in the slides that Sir originally created. Do you want me to go into details of any one of those or all of them?
No, sir, just an unrelated question, because there was, I think the graded question did not specify the evaluation metric. So by default, mean absolute error has been used.
Which week is it?
I think week 4. Let me get the question. I'll probably put it in the discourse. So.
Sure. So I think it was the last or second last question in the graded question set.
Yeah. So that there is no scoring method. I used mean absolute error. I got the number, but I wasn't sure whether that is considered as a default, because I thought R square is
There's a discourse post on this question. Like I think there's a detailed discussion on that.
Already a long discussion happened on this one.
So, Sir, I think if you do not provide any scoring method, by default, it uses, so cross-validation, I think you're talking about. So cross-validation will by default take the scoring mechanism of the original estimator. And in that question, actually, we are using Lasso. And Lasso's default scoring mechanism is R2 score.
Yes. Yeah, correct.
Right.
Okay.
Okay. So there is an important distinction when it comes to cross-validation regarding score versus error. So error, we say a model is very good if it has low error. And if we want to talk in terms of the score, then the model which has higher score is better. So cross-validation APIs that we have in sklearn, they work with scores and not errors. So we have to keep this point in mind. And these are some of the scoring functions corresponding to the popular error functions. So keep this point in mind when you are working with cross-validation. So let's say if you want to consider mean absolute error or mean squared error, we have to use the corresponding scoring functions, which is a negative mean absolute error, negative mean squared error. So basically, if you want to get a scoring function from an error function, we have to just negate it, and we are going to get a scoring function. Then we come to cross-validation. So sir has discussed a few methods to apply cross-validation. One is k-fold, second is repeated k-fold, next is leave one out, and I think last one is shuffle split.
I had a
In
question.
order,
So, yeah.
yes.
See, does the test time split that also does the shuffle split, right?
Pardon me?
The default train test split.
Right.
That also does the shuffle split, right?
Yes, yes.
And this shuffle split is specifically for validation.
Yes, absolutely. Yeah. Okay. So all these four are actually APIs in scikit-learn. So in order to use any one of these methods, you will have to create an object of these classes. And so let me increase the size of it. I think it should be enlarged now. So this, you can look at the code line, and there you will see that CV is equal to CV strategy, and CV strategy is actually object of one of these four APIs.
So here, like you are not, you don't give any scoring, scoring options, right? So by default, it will result R2, right?
I wouldn't say R2. So okay, look at this. Focus on this linear regressor, which is being passed in cross-val score function. So whatever the default scoring mechanism defined inside the class of this object, will be the one that is going to be used for scoring.
Yes.
And of course, in this one, we are not providing any scoring methods. So we'll come to next slide, where we'll see some of these scoring mechanisms. I mean, an example where we are providing the scoring function.
In cross-value score, we cannot pass the pipeline, right? It will only accept the particular, you can say model selection. Sorry, linear model sum here.
No, we can pass pipeline.
We can.
Why should we not?
No, as you told that whatever we are passing like linear regression, it is going to take that default that error part. Okay, whether it is R2 or F1. So if you pass, you can have a combination of like standard scalar. Then it can have a linear regression.
Right.
That time it is going to take the last one.
I think even in that case, pipeline will work. I'll tell you one interesting thing about pipeline. So pipelines are special objects, which are, even though they are combination of different steps in machine learning, the pipeline object itself is going to act as if it is if it is representing the last step in the entire pipeline. So for example, if I have put 3 or 4 pre-processing steps right before my estimator, and estimator is linear regression, which is going to be last step my pipeline, then the pipe object PIP is equal to, you have defined it completely, and the last step is linear regression. Then all the functions and attributes that are present in your linear regression object will be accessible through that pipe variable. That's an interesting thing about pipe. And if you want to access the previous steps, of course, you will have to use either named steps or treat it like a dictionary or an array.
So one doubt with pipeline and cross validation. So if the
Yes.
pipeline contains feature transformation like standard scalar or something, does
Yes.
it apply it separately to the training and the validation set within the cross valid, like within a particular run of the cross validation?
Sorry, I did not.
Meaning,
So what?
I have a train test, like I have a training set, training data
Okay.
set, and
Okay.
I have given cross validation as say 5 folds.
Okay.
So that would mean my data will be divided into 5 parts, and 4 will be used for training, 1 will be used
Right.
for testing, right? So will the standards, if I pass a pipeline into it, then will the standard scalar be applied separately to the training and the validation set, like like I apply the standard scalar to 4 and then to 1, or it applies to the entire 5 parts together?
Okay. Okay. I see your point now.
Actually, one of the, in that graded questions only, I think one of the codes, somebody was getting a different answer. And when I ran it on very large cross-validation values, then it became the same because it almost converges to the size of the entire data set, right?
Yeah, that is actually, it's a really unique one. You are unable to figure out. But if you go in discussion now, it will be over.
Okay.
Yeah, I think
I want to discuss that.
Sir mentioned in one of his videos that if you have to apply any sort of scaling, it has to be applied over all the data sets. So implicitly,
otherwise
I think
the results will be different.
It will be incorrect. So if it is if you are doing a cross validation, it has to apply on both the training as well as the validation part of the data. It has to. Otherwise,
Yeah, Sandhu, that we have to check it. But for this case,
but I think
somehow.
Yeah, I think it is Shreya's question was not that. Shreya's question was because see what happens is fit transform, right? Fit learns the parameters, the distribution parameters, transform applies them. So if you apply fit on 4 folds, you will get a different sets of parameters. If you apply fit on all the 5 folds, you will get a different set.
Yeah.
Right? And this difference can actually mess up. Right? That is how it was messing up. This week, I don't know how much time I spent on the assignments. Right? It took so much time till I figured this out.
It's an internal implementation, so it's not something that's visible. Like when you run
but it should be fit on 4, right? Typically, I mean theoretically.
No, it should be fit. It should be transformation of the 5.
Yeah, transformation of the 5. So
yeah.
Fit on 4, and then you test on the 5th one, which is your validation set, right? But then all these 5 should be transformed in the first place in one epoch, isn't it? Otherwise, your answer will be incorrect.
The question is more on cross validation. So after splitting into training and test, if you run a cross validation on the training set, it further separates into train and validation, right? The question is more on the second step, not on the first one. Like first one, we need to transform both. In the second step, all the cross validation related operations are internal to the cross validation function, right? So that we can't see what it is applying on, whether it's applying only on one or both.
But for that we have that is the reason why we changed the for example, for training and testing data, we have a separate data only for cross validation, and then we further split the cross validation data, right? So all the cross validation data, at least the cross validation data, should have the same distribution. So for that we have the same scale, if I'm not wrong, right?
Correct. But if you apply a pipeline internally, how does it do it?
Yeah.
Does it do it on all the 5 folds, or does it do it on 4+1? And my guess is it does it on the 4+1.
Yeah, I think it has on 4+1.
Yeah, that was the difference.
Yeah, you're right. That is internal. I mean, yeah, we don't see it, but I guess it should be all the 5 folds.
Okay, so for this one, Shreya, I'll have to do some digging and come back to you to give you
Sure.
proper
I also
answers.
tried looking it up, but there weren't too many resources available. So
I see.
Yeah.
So just a suggestion. This is how would I do. If you want to try it, you can also do this. So you can look at the source code of cross-validate function scikit-learn.
Okay.
So typically, this solves the problem faster than any other method.
Okay. I'll try that. Thanks.
Yeah. Okay. Let's go to the next point. And So
And
after you,
that, Swarnim, will that those codes have the practical examples in terms of data, like matrix data, solve those means to just
the
relate
source
it?
code you're talking about,
Yeah.
not at all. It will not have very formatted documentation. It will not have any examples at all. So it is like your bare minimum code that is being executed inside the scikit-learn library.
So actually, see, sometimes I'm not able to get into that because the code have not. We always rely on the matrix. Okay, just the matrix picture come into our mind, and then eventually not able to see. So can we get some kind of documentation where we can relate these in with literal examples, mathematical examples of any documentation if you have or something, any website we can refer.
So correct me if I understand your question incorrectly. So what you want to see is when we apply any scikit-learn library on let's say a feature matrix, you want to see what it is internally doing in terms of the matrix.
Yes, exactly. In each state, like the CV cross validation, what exactly the transformation is going to do, and what are the training state and all test set. So it will be easy to understand those things. So otherwise, sometimes I'm not able to relate something what is happening inside.
I see. That's a good suggestion, but I am not aware of any such resource. It is so what you're asking for is a quite detailed explanation of the internal working of scikit-learn with an example.
No. I'm not looking for a detailed working. I am just looking for each step, whatever the actually professor teaches us. If we can just visualize in terms of mathematical formula, like we learn in MLF, something on that perspective. Each step, this is something happening.
Okay, so
NumPy, you have to expert in NumPy, then you can able to get each and every feeling. It is very difficult.
Yeah. The other thing that I was trying to do is that I try to do a visual. I do this plotting of, particularly if I have applied a scalar, right? I apply the plot and then I just look at the plot again.
No. See, actually, sir, sometimes we can do the plotting, but I'm just asking each step, like when we do K means clustering, K just before the slide which we are talking about. If we apply that algorithm, what changes being done up to the data? So that we can't see in the visualization, right? That will have to see in terms of data only, that matrix or something like that.
See, so again, this is good. I'm pretty sure that this this kind of resource, if it is available, should be really, really useful. But I'm not aware of it if it exists.
Okay. Okay, student. Thank you.
But for anything else, I mean, if you have specific questions regarding any one particular method, you can post. We can have a discussion on that on Discord. If you like to, let's say, understand cross-value score and how it is working, you can write your understanding as I think Shreya did for one of the topics, and we can have we can start a discussion on that.
Actually, some of the session professor have detailed it in terms of matrix. So I'm just looking for everything in terms of that, but I haven't get that. So I was looking for that. So I inclined to that examples.
I see. So change in matrices that happen during the invocation of
each
your
steps. Yeah, each steps. Right.
Yeah. So that will be tough to find. I'm pretty sure that might not exist at all. I suspect. Because what you're asking for is absolutely mathematical view of an sklearn API.
Yes.
Right.
Break up everything in NumPy.
Yes.
It's very difficult.
That's the best way. And as Srinivasan sir said, visualizations are quite helpful. So try that.
Hi, can I one thing, Swarnim?
Yeah, please.
Yeah. So Srinivasan sir, so I think what you are asking for is actually the main paper which came. So that will be very helpful if you can check. About one particular thing, whatever you found, if you can check where it was invented and who actually proposed and find that scientific paper, then you will get the actual thing, the code thing. Okay. that maybe you have to find. But for whatever you're interested, if possible, if you can find a research paper, then that is where the research paper is actually coming in picture. Okay, just if you can take some time and find that, that will be helpful. Maybe. I mean, Swarnim, is that right?
Shreya ma'am, if I'm not wrong, you asked what is the transformation between the 4:1 data, right?
Yeah, does it do the scaling on this 4:1
Yeah.
separately?
So just a gist of it. Okay. So all these things now, they work on one thing called IIDs. So they are just independently and identically distributed things. Okay. The whole machine learning main assumption is we have to have IID samples. Okay. To work on anything. So in the gist also, just it's a very vague way of saying, but the data, whichever transformation method or whichever pre-processing or cross-validation, any type of method we are using on the data set, for transformation, it needs to have an IID sample. Otherwise, all the pre-processing, all the results which you'll get will have dependencies and which will not work properly, basically. So the basic assumptions of all these models which we are currently doing, the IIDs, so they have to have a same distribution. So that relates to same measure, basically, same kind of, they should look similar to each other in the sense.
So one point I would like to add, that is, even though it is true, but once you divide the data set, so we are talking about pre-processing. Her special question is, how does the pre-processing happen for cross validation? So if you remove some of the samples, the range might change. And if the range might change, your min-max scaling or standard scaler will give you different results.
Yeah. So the confirmation for that is if you take a large cross-validation set, that almost gets the training set close to your actual data set, which shows the same results as without cross-validation.
Yeah, I mean, and it also depends on what method of cross-validation, because every method have better in the sense of they are they might give better results. So for convergence, if you know there is a theorem called, like, if in a vague sense, again, central limit theorem.
Yeah.
So what it does is centralizes the data, right? So for that also you require a minimum subpar type of data set. So for distributions also if we want to make the distributions to be identical, you need a bigger data set to make it identical. That's why most of the machine learning data sets are quite big, quite heavy, so that we can do all this pre-processing very neatly.
Okay, got it.
So say, for example, like when you use a simple pipeline and then you call the predict method on that pipeline itself, okay, like on that regressor, okay. So that time also it has to do those pre-processing, right? Now with cross-validate or cross-val score, so basically if we can pass that pipeline itself, right? So for each epoch, okay, for each epoch, like four guys, like fourfold it has taken for training, and that will be of course transformed, right? Then you will get some W, and then when you are predicting, because the score by default you return is on that validation score, right? That on that one fold. Now when you want to predict that, so that time you have to use that regressor. So that means that transformation has to happen on that X on that particular data fold as well, right?
Yeah, exactly. It needs to happen. Otherwise, it won't have the identical distribution.
See,
the distribution
Rajiv, what you are telling, that logic is working same way. But when you going to be do one by one, and the same thing you are applying in pipeline, the objective or the answer should be same. Agree? The pipeline also working in the same way if you are going one by one. But in case of example, the score function and the alphas are coming different. That is the problem Shreya is telling, okay? And we have put in the discourse, you just take the copy of the two source codes, okay? And you just run and you say where the mistake has done from our side. That is the problem, okay? Our other from what concept you are telling, we agree. Without scaling, the training and test data should not work because it's not well distributed, or you can say it's not well scaled in the same platform. You just try both the example, you will feel why the
difference. Yes. I think after the quiz, we should all just have one WhatsApp chat on this one.
So it is on graded GA4 or what?
Yeah, GA4 last question.
GA4 last question. Okay.
Yeah.
Okay, I'll also take a deeper look into this. So I understand that this discussion is triggered by the mismatching answers in the graded question. Why with pipeline we are getting different answer, and without pipeline we are getting different answer.
Sir, while here Srinivasan, one request, of course, not for this quiz, it doesn't matter, but in the future things, right? If the graded questions could have, instead of a NAT, if they have a MCQ, at least we get an idea that this is wrong. Right? So what happens is sometimes I get 0.589, right? And the range is 0.59. So I know that there is some small mistake I've done, but at least I will know, I'll get an internal feedback that yes, I am doing wrong, right? So if I don't get all this answer, but that's for the later graded questions. Thank you.
Okay. And sir, I would like to add, if there are errors such as small as that you mentioned, we consider your answer correct.
So let me check what my score was. So
okay, sure. So now we are up to the last part. Once we have done the cross validation. How can we get the results? So this particular piece of code is actually taking one of the cross validation methods, shuffle split. Okay, the number of slits are 42 and test size 40, sorry, and test size is 0.3. And the scoring mechanism, this time we are using two scoring functions rather than just one. So in this way, we can actually provide list of all scoring functions into that scoring parameter, and still our cross validation will happen. We also want to see the scores after the entire cross validation process, and that's why we are passing this parameter return train score is equal to true. And we also want to see the corresponding estimators, and that's why we are passing return estimator is equal to true. And there are some other attributes you also get in CV results. For example, you get the fit time, the amount of time which was consumed to fit the model on corresponding one execution of one strand of execution. And similarly, the fitting time, as well as you get the prediction time and other attributes also. The most important ones are the scoring, test and train scores, as well as the corresponding estimator that you get. So I think that's all from my side. Any questions?
Practical, I couldn't answer. So cross validate and cross validate score. Is there a reason we will use cross val score, that method at all, or just cross validate seems to do everything?
Yes, cross validate is it will provide everything that cross validate score is doing. So there are different methods. You're free to choose which one suits your needs.
So the only difference that has been highlighted is like the scoring parameter, it can take multiple, whereas like cross-val score can take only one.
I think cross-val score should also be able to take more than one.
No, in the lecture, like it was mentioned, like cross-val score can take one, and cross-validate can take more than one.
I see.
But there is no other. Is there any other practical thing? There is nothing else. Right?
No other thing.
Okay. Yeah, this happens in committees, right? So if two people are very passionate about the names, finally they decide that we'll keep both names. So
yeah.
So just one question on the quiz question types. Are we expected to know if a particular parameter is legal or not? That would mean knowing everything that can be passed into the parameter, right?
So, Shreya, I would suggest yes, that is expected.
Okay.
At least the ones that sir has used in his examples and the ones he has shown in the slides.
Okay, like what I mean to say is there could be something which is not covered, but is still legal or valid. So, like, will those kind of things also be there? Because that would mean reading the documentation and knowing what all values can exist for a particular parameter, right?
I would say that should not happen
Okay.
because there are practically many number of parameters, and one cannot remember the names of the parameters as well as the acceptable values
Right.
that could go in.
Actually, it happens in one of the questions, right? Mean, it was mean percentile, and there is mode is also there. So we confuse whether mode is applicable or not, and mode was not discussed. Right?
It was mean, median, and quantile.
Yeah, mean, median, quintile, and mode was there. So I thought mode can be the quintile can be the. So there's a confusion. So I just.
So mode is not acceptable, right?
That is a trick question. No?
Yeah,
Mode
constant
is,
is
mode is,
the-
yeah, mode is acceptable in the imputer, not in this.
Yeah.
And that is also called most frequent over there, not most.
Yeah. Okay, got it. Thanks.
Yes. So I think that is all from my side. Jimmy, would you like to take over?
Yeah. I'll share my screen. So is it the screen visible?
Yes.
Yeah. So since all other instructors have already defined like how to prepare for the quiz, so I'll go through that quickly go through that MLP week 4 content. This week mainly we discussed these 4 topics like polynomial regression, then what is hyperparameter, how to tune it, and we tuned it on the for the regularization model. And there was last part in which we covered the demo. So mainly the demos implementation part covered in these topics, and the maximum time was allotted to that demo part. Okay. So so we'll start with the polynomial regression. So basically we follow the 2 steps to train a polynomial model. First we transform the feature matrix, and then we apply the linear regression model, like whatever it is, like normal equation or SGD. Then in the polynomial regression, this is a code snippet taken from the search slide only, like where we applied where we have shown the pipeline for polynomial regression. If we have to use that linear regression, then we will put here as a linear regression, or if we have to give SGD regression, then we can change it to the SGD regression. Okay, so that is what is shown here. And then there is one more feature, one more argument we can say that that is interaction only, like which we can set true to exclude that higher order terms. So that is all. Then we talked about the hyperparameters. Obviously the hyperparameters, the parameters which is not directly learned from the estimators. It is just like a knob of your algorithm which you can tune it. And here some model parameters and hyperparameters are collected here, but obviously there are few hyperparameters like max depth which is not covered till now. So these will be covered in that random forest and all. So and then there are 2 methods again to tune the hyperparameter, like a grid search and randomized search. So what grid search do is like it literally make all the combination and try our model based on each combination, and gives the result which gives the highest score value. And as we already discussed, like the scoring method we can set that also in the model. And but randomized search, like it samples a given number of candidate values based on some specified distribution. So it is good, like if we have large number of hyperparameters or large number of hyperparameter combinations, then it's better to use the randomized search. Or else for a small set, a small number of hyperparameter set, we can use that grid search. Okay, so these are the steps which we usually follow to tune the parameter. Like first we divide the data, and after that, we just try out each combinations on the training set, and we evaluate our performance of the model on the validation set, and whichever gives the highest evaluation score, we train our whole model on that parameter, that hyperparameter, and we get the final model performance based on the test set. So again, this is a sample code snippet screenshot taken from the search slides only, here how the grid search, all the parameters as mentioned here. Here it was mentioned the scoring method was taken as a negative mean square error, and here what are the different parametric is there, CV equals, all these things are there. Then the next topic comes how to set these things in, how to implement these hyperparameter tuning methods in regularization. So first, we all knows how we can train the ridge model and lasso models. So what we do is it's just there can be two ways. First, directly import that ridge estimator, or we can use it using that SGD regressor estimator also. Here we can set penalty equals L2, L1, or elastic net. But just that if we will use elastic net, then we have to put one extra term, which is L1 ratio or L2 ratio. That. Okay, so similar kind of thing we can do for the lasso also. We can import that lasso model, and we can set that alpha value. So since we know that our model performance can change with just by changing that alpha value. So for that only, we will use the hyperparameter tuning. So or otherwise we have also one few methods, we can import the rich CV, lasso CV also to do the cross validation. Then the ridge regularization, it is a sample code for how we just this one here is what no so how we use that ridge regression after just changing in this code. Just applied the ridge regression. It's simple ridge regression only. We haven't used we have given the fixed alpha value here. So maybe in the I think I just missed one code snippet. I was expecting that in the final one, I have kept that grid search part, and based on that final code snippet where we have used kept the ridge and all the alpha values and all. So I think that is already there in the slides, so you can refer that. So in this week, mostly what we did, we just focused on that implementation part, whatever we learned from week 1 to week 4, and we just tried to implement all those things in the final model. So that was more this week was more about the implementation part, and we tried to cover all the things whatever we learned in the week from week 1 to week 4. So week 4 itself is just summary of all the weeks, just if we remove that parameter tuning part. So I think more or less that is what we have in week 4. So
Sir, actually I have a doubt in the mock test, if you can go there.
Mock test?
Just on I think second last or third last question. Can you please go there?
I open that part. Mock test, I'll have to open it.
If anybody can open any of the
that would be better, because I have to log in for that ID.
If I'm not wrong,
in the last question, there is actually seems to be an error in the answer, right? That is are you talking about that? The parameter is
the SVC one, the SVM one. There are 2 kernels given. I am asking about that.
Just repeat the questions actually.
Let me share screen, Ajmi.
So the response I got was that you just need to know that this is a parameter search and just apply the thing. So the actual code is covered in week 5 and later. And you can also look at the last question also, second last as well as the last question, because both of them seem to be some issue. So
This one, the 20th one and the 21st. And also there is an error in the dict vectorizer one, because there is no thing called get features names out in dict vectorizer.
You can see the screen now.
Yeah, perfect. This question, exactly this question.
Yes.
So question number 20, how many candidate models will be created? Okay, so what it is asking is you have passed 2 parameters. So again, as I mentioned earlier, you are not supposed to know the meanings of what kernel and what C is, but all you have to know is that you have to, estimate, make an educated guesses that these 2 are parameters of support vector classifier. And it's a perfectly valid code. You'll learn more about support vector machines later. So now there are 2 possibilities for kernel and 2 possibilities for C. Okay, so you must know that what does grid search do? So grid search, exhaustively creates all possible combinations of the parameters and then does the search over those. So you can see that kernel has 2 and C has 2 values. So 2 by 2, there should be 4. These many number of candidates it will create and do the cross validation and get the best one out of these 4.
Okay, no problems. Thank you. And also in
the last question, is there an error in the answer?
Isn't it
21st question 21?
21st, yeah. Isn't it should be classifier and then the C variable, something like that?
Let me read it. We want to find the best C through a grid search where C takes values from 0.1, 1 and 10. Okay, parameter grid is something. Okay, fantastic. So what it is asking is, see, the grid search, you are passing the parameter, which is the estimator is a pipeline object, not a plain estimator. Okay, so what this question intends to find out is, do you know how to pass grid search parameters to a pipeline object? That's all it wants to ask. Okay, now go above a little bit where this, yes, see, so scalar. So first method is scalar, which is standard scalar. There's nothing over there. The second step is classifier. The name of that step is classifier, and the estimator is logistic regression. So you must know that if you want to pass a parameter grid to a particular step of a pipeline, how should we do it? So what we do is the name of that step, which is classifier, that followed by 2 underscores, and then the name of the parameter.
No, that's the answer I wrote, sir. But the here that it's taken last second as the answer.
It's it should be classifier underscore C, right? The answer should be.
That I totally agree with you. Yeah, it should not. It should be, I think, B1.
Yeah, it looks incorrect.
And also there is an error in the dict vectorizer question. It should be dict vectorizer dot get it's below.
Question number?
I don't remember, but it's around 18, 19.
No, there are basically the there get features and get features out. Okay, feature names out.
No,
Both
there
are
is
there.
no. There's only get feature names and get features.
No, this one is actually working. Can you?
Yeah, it is
check?
working. Get feature names out. It works.
I can show you. I just want to check.
One mistake. Yeah. No. So one mistake I can find in this piece of code is there is a missing underscore between 2 array.
Between, sir? Sorry.
2 and array. I think it was a typo in the question itself. The second last line of the code.
Okay, got it.
Yeah.
Here the answer should be city is equal to Chennai, right? And then option D should be correct.
To array transform measurements. No, it should be Chennai 33. Get
No,
feature.
surname 2 underscore array is wrong. 2 array.
No, 2 array. 2 array.
2 array is right.
Yeah,
2
it
array is
right.
correct. 2 underscore array is wrong.
Yeah.
Okay.
That is as array. As array probably like there is a underscore.
Yeah, as array has underscore. 2 array doesn't have.
2 array doesn't have.
Okay.
Output is coming. This one I'll just post in the chat window. Output is coming.
Actually, to be precise, like say for example, if you have these 33, 18, and 12. These are categorical features. Then it will it reads write all the categorical feature correctly, and only the numerical feature it doesn't write, right? It is only writing temperature.
Also, I wanted to ask, it basically makes the categorical variables as the column names, right? And the main frame or matrix will only consist of numbers, right? In any form, maybe one hot encoded or.
No, it's a dictionary vectorizer. It will take Chennai, Kolkata, Delhi, 18 and 12. And after that, it is asking only to get the feature name. So Chennai, Kolkata, and Delhi is going to become your feature. And then they're converting into 12. So this 13, 18, and 12 will not come. If it's asking the entire one, then it will come as a vector. Chennai,
Okay.
13, Kolkata, 18, and Delhi, 12. So asking the feature.
No, the last line of the code, if you see vectorizer dot get feature names out, right? So here it is like when it feature names what? One is city, another is temperature. Those are features, right?
Correct.
And if you see Chennai, Delhi, Calcutta, those are basically feature values corresponding to city, right? In the output,
Dict vectorizer will make them also into features, right?
So
Chennai,
dict vectorizer
Calcutta
is make as a matrix. That means it becomes Calcutta, Delhi, then 33, 80, and 3/2 cross matrix.
3/2 cross matrix, right? And if you see the gate feature names, what are the feature names? There are two feature names. One is city, another is temperature.
Right.
But see the output. For categorical feature, it is spelling out what are the values as well, not for the numerical feature.
Yeah, because see, the dict vectorizer, Rajiv, that's what dict vector is supposed to do, right? Because it will take those categorical values, create them as separate columns. So that the features themselves will be re-encoded, right? It will become, instead of a single array, right, of strings, it is going to become a 3 by whatever matrix, right? X by 3 matrix.
So
right? Plus the temperature. So the output will have, after the encoding, you will have four features.
Yeah, that's correct. So dict vectorizer also implements one hot encoding of categorical features, right? So it's basically doing two things.
No.
So implicitly, it also takes care of categorical features and does one hot encoding on that.
So one column city equals to Chennai, one column city equals to
Yeah.
Delhi, one column city equals to Kolkata.
So if you print the entire array, right, it will be Chennai. It'll be then 0, right, and then 33, right, and then next thing will be 0, 1, 0, 18, and then 0, 0, 1, 12.
12, yeah.
But dict vector, in the slide, dict vectorizer will not do that one hot encoding of its own, right?
Right. Yes.
It will not
do
that.
Rajiv, if you look at the Scalan documentation, it specifically mentions that it will do the one hot encoding of any string features that it has. So in all the string values of features, it will be converted or rather transposed into columns. So it does.
Oh, okay. It is written already. Okay.
So should we remember these output, get feature names output, what exactly? So it's something difficult sometime for other commands. I'm just wondering how we can tackle this.
I think going through source code and solve with instructor session is sufficient. You can check.
Okay.
It will not be more difficult than this. That much I can say. Honestly.
The only thing I did not remember was between option B and D. I was confused whether what would be what.
Right? You guys did not.
No. I mean, remember, right? I mean, I practiced it. Then I realized that okay, because the column names have to encode the original feature name also, right? So that is how I guessed it. Otherwise, B and D are quite confusing, no? Because either of them could be the right answer depending on how the label is named, how the feature gets named.
Understood. So best way is obviously to again paste it in Colab and check. But yeah. In quiz, that will
It
not be.
should
That
be-
Yeah,
will not
quiz
be
they can't do
possible.
it. That is-
Yeah, I understand that. I understand.
See, it's written should be like city hyphen Chennai. City equals Chennai.
No, it won't be city hyphen Chennai or city hyphen Chennai. That will be the value. So
Yeah.
No. It is coming city equals to. You just
Equals to.
paste it in code Colab.
Yeah, it's coming city equal to Chennai.
I need to read it.
So that is the
Yeah,
feature
yeah.
name. Okay.
Yeah, exactly. Feature name city hyphen Chennai. Then okay, I don't know.
And there are some activity questions where they're asking like under sklearn what are the different sub modules are there. So should we remember those things? Means those questions being asked in activity questions. Like
Can you tell some specific questions?
I think in
Actually, I have some doubt in this dict vectorizer only. Can anyone explain that? So this array which I have pasted, what it represents, I'm not understanding that.
Yeah, even I'm not clear, like, why is it printing Chennai, Kolkata, Delhi?
So I think the first three columns represent the one-hot encoding of Chennai, Kolkata, and Delhi.
So it is okay. So does that mean that one represents Chennai in the first row?
Actually,
first-
I think yeah. Go
Yes,
on,
DJ,
sorry.
please proceed.
Yeah, so I think it is somewhat wrong. I mean, first one I think should be Chennai. Chennai, as far as I understood it, Chennai is first row, first column. Okay.
Yes.
And so the corresponding, then the next column is city equals to Delhi. Then the third column is city equals to Kolkata. Fourth column is city equals to our second column is city equals to Delhi. Third column is city equals to Kolkata. Fourth column is temperature. So for Chennai, which is first row, first column, temperature is 33.
Okay.
Then we have Kolkata. Kolkata is on third column, right? City equals to Chennai, city equals to Delhi, city equals to Kolkata. City equals to Kolkata, third column, temperature, how much? 18. Then city equals to, then the fourth row. Third row you come, city equals to Chennai, column 0. That means there is not city equals to Chennai. What do we have? We have another thing. What do we have? We have city equals to Delhi. Delhi comes now in the second column. Fine. So city equals to Delhi, not city equals to Kolkata. So not city equals to Chennai, not city equals to Kolkata, but city equals to Delhi. Right. So not means 0 and the but portion is 1. So what is the corresponding temperature of Delhi? Delhi corresponding temperature is 12. Okay.
And also the output comes in I think it comes in an alphabetical order, it seems. Because I thought
CDK, is it?
Yeah, I think it's CDK instead of.
Yeah, I have to check on that. I am not sure whether I have to check different applications. Swarnim, any thoughts? I don't know. Actually, whether it comes in alphabetical order.
Yes, it comes in alphabetical order. That's why Delhi is getting the second.
Yeah.
Yeah.
For other vectors, I would.
But what will happen if there is a numerical value that we have to find out? Say about city equals to 1, 2, 3, city equals to 4, 6 or something.
Then in that case, dict vectorizer, so as long as the value corresponding to that key is all of them are strings, then it will do the one-hot encoding. Otherwise, it will just extract the numbers.
Yeah,
exactly like it is doing for temperature.
Question. Yeah, what we saw in the in the lectures also for the height and the age.
Okay, so I think that I hope that solves helps the issue.
Okay, so the way we read this matrix, which we have got the array, which I have pasted. So because Chennai is in the first column represents Chennai, so that's why it is 1 in the first row. Okay. The second column is Delhi, so it is 0, 0, and 1 in the third row, right? And then
third row.
No, second column. Second column.
We name the cities per column, right? The first column is for Chennai. Second column is for Delhi. And third column is for Kolkata. So I'm reading it column wise, right? The first column is 1, 0, 0.
So for Chennai.
Yeah. And the second column 0, 0, 1. That's
Kolkata.
Because Delhi is in the third entry of our
alphabetical. So third entry.
And then the third column, which is Kolkata. Okay, so we have 0, 1, 0. That's because the middle value is Kolkata in our given input, you can say.
No, third row, second column is 1, right?
Third row, second column. Column number index is you can say index is 1 for that. I'm not understanding.
The value is 1, right? See, first column is 1, 0, 0.
Yes,
right?
correct. That's correct.
First column is 1, 0, 0. First column is city equals to Chennai.
Correct.
Second column is 0, 0, 1. That is city equals.
Hello.
Right.
So can you repeat? I lost your voice.
Second column is 0, 0, 1.
Yes.
That is city equals to Delhi.
Okay, Delhi. Yes.
Third column, come to third column, 0, 1, 0.
Okay.
That is city equals to Kolkata.
Okay.
Okay. Now, what does this mean? First column was city equals to Chennai. So, city equals to Chennai is 1. First row. Okay. Now we are going row wise. First row, city, first row, first column. That is city equals to Chennai, but not city equals to Kolkata, and not city equals to Delhi. Or sorry,
Delhi and
city,
Kolkata.
not equals to not city equals to Delhi, and not city equals to Kolkata. Temperature is 33.
Okay. Yes.
So for Chennai, temperature is 33.
Yes.
Second row, you go city equals to not city equals to Chennai, not city
Delhi.
equals to Delhi, but city equals to Kolkata.
All right.
Temperature is 18.
Okay.
In the third row, not city equals to Chennai, but city equals to Delhi, and not city equals to Kolkata. The temperature is 12.
Okay, perfect. So that's how it was. Yeah. Thank you so much.
Okay.
May I ask one more question from this mock?
Yeah, please.
If you can explain that log 1p. The
log 1p is yeah. So log 1p does the log of 1 plus the value, right?
Okay, 1 plus the value.
Yeah. You go through the manual. Just a minute.
See, you have to remember that
log with the base 10, right?
Yeah.
Anything, but log 1 basically adds 1 to the value, so that 0 will also get a value.
So will it be log to the base 10 plus 1? Is it like that?
Number plus 1 to the base 10.
Yeah. And similarly, it has a dual. Not look good, but yeah. So there is a dual of it, dual or complement of it also. That is exponential 1m. Okay. See, log 1p means what? Log of 1 plus p means plus. I mean, that is how I remember. I think that is how they also made log of 1 plus the value. Okay. Another thing is you just check in the SQL and manual also, sir. Okay. So there is a exp1m. Okay. exp1m means exponential 1 minus the value, given value. Okay.
Okay.
So these are some of the small things. Okay, you just go through the SQL and manual. It's just log 1p is there, log 2 is there in slides. Log 1p is there in Colab also. Okay, somewhere they incorporated in week 2. Check once. Okay.
Yeah, that function transform.
Yeah, exactly. Function transform. Thank you.
And log 2p doesn't do this that
log
addition
2p is not there. I think log 2 only is there.
Oh, log 2. Sorry.
Log 2 is there. Yeah.
Correct.
1p, the way I understand is basically because you have 0 values. If log of 0 will become infinity. So the 1p basically just transform the entire thing plus 1 so that there is a proper log values for the entire.
Right. Yes. Correct. That's the definition.
Okay.
DG, can you please confirm that this does the natural logarithmic or base 10 logarithmic?
Yeah, I'm looking for the log 1p.
As per documentation, sir, it is natural logarithm. Right. Ln it is.
I see.
Yeah, morning I also trying, but different value. But as per answer, it is going for the natural logarithm.
Okay, so then. Yeah. Okay, I also have to find. You guys just carry on your discussion. I'll get back to you.
I think it is natural log ln.
Yeah, I saw somewhere. Just natural. So I'm checking the NumPy manual. I'll post the reference also in the chat window. So it is actually the exponent natural log only. Okay. So it is saying that it returns the natural logarithm of 1 plus the input array element wise.
Okay.
Okay. Yeah. So the reference is given and this is the. Okay. Yeah, so Swarnim, I think that's it from my end.
Okay, so if there are no more questions, can we close it? Swarnim, are we done?
Yeah, of course.
All right.
Anybody would like to ask more questions?
No, I think that's fine.
All right.
Okay.
Thanks everyone.
Thank you.
Bye everyone. Bye.
Thank you.
Bye then.
Thank you
All
all.
the best for your quiz.
All the best for the quiz.
Thank you. Thanks.